everybody, and hopefully you're going to be wide awake post-lunch mini coma. Hopefully I'm going to wake you up. So we're here from Desk. I'm the head of science at Desk, and Claire Duncalf is our head of Key Stage 3. And this is Sarah, a Year 12 student, who's happy to do any translation if anyone would like some Arabic translation. So, if you want any translation throughout them, please ask Sarah to come over, and she's happy to come and explain anything for you in Arabic. At Desk, we have a philosophy of helping the students to build their thinking skills and helping them be really engaged in their learning. It's crucial that this happens across all subjects. So this is an example of a poster that's in every single room at Desk, every single teaching room, so that we can talk to the students frequently about the different skills they're learning all the time. So they're developing their independent learning skills, they're thinking about their communication. So this is a really fundamental part of the whole school, across the school. This is really crucial to our message. So in science, as we know from today, and I'm sure everybody knows already, that contextualising science is really crucial to getting the learners motivated and performing highly. This is on every single door in the science department. This is our science vision. Now please don't feel you have to read everything, but this in bold up here, the fact that science needs to be exciting, interesting and relevant to all students. And what we're trying to do is make sure that students are scientifically literate, whether they stop learning science at 16 or whether they carry on to be astronomers and neuroscientists of the future. We need to make sure everybody understands how science fits into their everyday life. So, at Key Stage 3 particularly, we teach a very context-driven curriculum. What we do is we introduce the students to different topics frequently. So, for example, we're going to talk today about particles and how they don't just learn particles as we're doing particles now. They're going to come back to particles again and again. Changing state is going to be a fundamental part of several topics, so that they're not just learning something once, they're learning about various different things in one context, in repeated contexts. We're hoping that this interest that they generate will help them in their post-16 study if they carry on, or if not, just engage them with interest in science for their everyday life. So this is an example of a Year 7 unit. So this unit is called Forensics. In Year 7 we teach 6 different topics. They're alien, we've got accident and emergency, extinction, and this one is forensics. So right at the start, the students are introduced to their mentor for this particular unit. So this is Dr. Cheryl. She's going to be giving us some bossy instructions as we go through the unit. So in this case, the students are taking on the role of forensic, they're training to be forensic investigators. So, Dr. Cheryl tells us early on of an exciting, dramatic event. There's a break-in at an art gallery. So it's immediately trying to capture the interest of the students. We get a statement from the guard. So the guard must have fallen asleep in some way. He suddenly became very drowsy, and then when he woke up in the morning, there was a broken window and he called the police. So the next stage is the crime scene. So we've set the scene, now we've got a crime scene. So the students are given this crime scene, and they've got to first of all start discussing and trying to think, what could have happened? Are there some possible scenarios? We're all the time trying to engage the students so that they are actively involved in their learning. So let's make sure you're actively involved in your learning. On your table, there is an A3 piece of paper of the crime scene. Now, instead of you trying to work out what happened in the crime, as the students would do, we would like you to try and think about what kind of science you could teach with all these relevant clues. So, for example, I hope some of you might have some ideas of some Year 7 science that you might teach for each of these different clues. Okay, quick chat with each other, go.
Can we teach about plants?
Sure, you could talk about this all day, come up with all sorts of theories, but for now let's just get a few ideas. So is anyone brave enough to just give a few ideas? Yes, over here.
I think it's about the genetic material, the chromosome, the fingerprinting.
Yeah,
that
great.
could
So
come
we've got
there.
excellent. So we could perhaps try and have a look and see if there's any genetic information left behind. We could talk about chromosomes and cells. Absolutely. Yeah, great. Thank you.
For a grade 7 level, I can talk about materials, where I can talk about, then classify as metals and non-metals and move forward.
Excellent. Yeah, exactly. And even linking there to the glass. Think about why the glass is broken. Exactly. Great. Yes.
Connecting to that classification of plants.
Yeah, we've got plant in there. Let's use that. We could go on to classification. Thank you.
Talk about electricity because the door is fitted with alarm.
Yeah, we could make our own burglar alarm. We could see was the alarm faulty, was there something wrong with that? That's a great idea. Thank you.
Probably we can even substance traces found on the floor.
Great. Yeah, substance traces. We could do some chemical analysis of those substances. Fantastic.
We can use also we can do measurements in physics, distance and the things, the light traveling through the broken window and the distance and the angles and all.
Yeah, definitely. Exactly. We get onto some measurements and think about how someone could have done something, tampered with this scene some way. Yeah.
We can talk about forces
Force.
because armchairs.
Sorry, I missed that.
We can talk about forces because
Force
armchairs.
as a chapter,
Yeah, definitely forces. We could,
pushing force and pulling force.
yeah, excellent. So we could get so much science into this scene.
Excuse me,
Yes.
you said that you are going to teach this at year 7, right?
Yeah.
So how do you limit the topics? What is the boundary?
It's a great
you can
question.
go to any extent, right?
Absolutely.
Right.
And that's part of the joy of this, is that you can, with students who are really interested, you can accelerate students and you can introduce them to all sorts of really quite advanced topics. However, obviously there's a limit. And what we do with this particular scene, this particular crime, is we are looking at the substances, we're introducing them to solubility, so they've got some known substances of known solubilities. They're investigating to see if the powder that was left behind could be any of those. So that's just a simple way to introduce solubility. Nobody mentioned the orange juice. So the guard might not have just fallen asleep, he could have been drugged, he could have been poisoned. So we are using distillation to see if the orange juice is still pure. And that's a really effective one. We can look at boiling points of different substances and see if those substances appear in the orange juice sample that we've got from the guard. Chromatography. Could this painting be a fake? We could look at some different types of inks, different types of paints, and see if they match, to see what kind of hunch we can make about what happened in this crime scene. And as people have said, there's loads of other things that we could bring in. But what we'd like to focus on today is thinking about this particular learning objective. So this learning objective is to explain what happens to particles in changes of state. It's obviously something that everybody's very familiar with. Well, we haven't mentioned particles just now, and I'm just going to ask some of our students who aren't here, who've made a little video to show us how they did this. Can I just warn you, this video was entirely made by the students. So please forgive them if the lighting isn't perfect and the explanations. They decided how they were going to do it, and here we go. They're going to explain how particles are relevant in this crime scene. So, we just go to
This is the crime scene. A valuable painting has been stolen from the art gallery. We're going to do a test for fingerprints using iodine.
What I am doing here is pressing my fingers on filter paper, and while my friend is putting iodine balls into it, I fold the piece of paper and put it in, and then put the bottle on top. Then we put it in hot water, and then the iodine is changing from solid to a gas. The particles get heated and then start to separate and move faster and quicker. This process is called sublimation.
This is an example test tube that we made earlier. This is what it should look like.
صافي الصراحة راح الصورة كتير باينة. أما بدنا نشوف الفينجر برينتس بالأيودين هنشوفها مين أخذها. حطوا بالتستو حطوا فينجر برنت من حدا من زيت وحطوا الايودين فيه رجعوا حطوا مي ساخن بالكباية حطوا التستو بالماء الساخن بعدين هلا بدهم يشوفوا شو بصير بس يروحوا الزيت من الايودين بالفينجر برنت.
Right, so you've got a sample that's been brought around of what this iodine fingerprinting technique shows. So hopefully when the lights come on, you should be able to see it's actually really effective, a really effective method of seeing the fingerprint. So hopefully everyone's got a sample on their desk they can have a quick look at. Okay, I go again. Okay, so using the iodine technique to try and identify if there are fingerprints there is one way of introducing particles. Now, usually at year 7 you might not talk about sublimation, about the unusual property of iodine moving from a solid straight to a gas, but here in year 7, well, why not mention it? Let's explain. This is something they can handle. It's not that hard. They can use this, they can use the idea of the solid iodine moving into the gaseous state. Hello? Feel free. So, just a little bit to explain how this iodine fingerprinting might fit into the rest of the topic. This is a map explaining the way that we would do this. So we first of all engage the students with the forensic, we've got this crime scene. Next, we'll be trying to consider how we might show the fingerprints. They use the iodine technique and they also try out charcoal, brushing the charcoal really, really gently with a paintbrush on the fingerprints so they can compare techniques, they can evaluate. So all the time they're building up these different skills as they go. Learning about particles and the change of state. And we come back to this, as I said there, when we talk about the orange juice and the distillation, of course, particles are crucial in then the particle model, changing the state, again, is a vital part of that. And then finally, students need to consolidate this information. We don't just, go ahead and do lots of fun crime scenes and leave it at that. It's really important that students demonstrate their understanding, but we want them to do this in an interesting way based on the context. So rather than just setting them a test on particles now, let's try and get them to do an assessed task where they have to include information about how the forensic team found the fingerprints using particles. We've got some examples of the sort of thing that a student could do. Now, within this forensic topic, we have this crime scene, we have a murder, blood spatters going everywhere. We've got all sorts of exciting things going on during this forensic topic. We've got a kidnapping, which can be a bit traumatizing, but so everything's fine in the end. Here's another topic. So that was forensics. This is a topic called cook. Again, this is in year 7. And in this role, the students are apprentice chefs. So they've got to try to think quickly and they've got to learn fast. And the guy who's the scary chef is a little bit like Gordon Ramsay, if anyone's ever seen any of those scary TV programs, but anyway. So, we are revisiting particles in a new context here. We don't say, we're learning particles again, and everyone goes, oh, we've done particles, boring. We are, again, introducing them to particles. So, can you have a think in your groups, have a quick chat with each other, how could you come back to this learning objective through the cook context? Quick chat with each other, how could you do this? Go. How could particles be relevant to cooking? How could we get them learning about particles with cooking? You get quite elaborate, thinking in science. What sort of ways could we bring particles into cooking? Would anyone like to share any ideas? Yes? Baking, exactly. And we make pancakes, and we're looking at the way that the particles change in the different substances. Yes? Boiling, yes, boiling, we can get evaporation, so we can cover we can really get into texture. Has to be perfect, it has to be very, very tiny crystals, so they've got to make it cool really, really quickly. So you'll see on your desks, there should be a bag, just that you don't have to look at this for long, but this is just a method of how we get the students to make ice cream. So we've given you 2 Ziploc bags so we can try and describe it. But basically, we put all the ingredients in the small bag, and then we make sure they seal it very, 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 very tightly, otherwise the whole thing is a horrible mess. And inside the big bag, they're going to put loads and loads of ice and loads of salt. Seal it all up and shake it and try and mix it all up, trying not to break the inner bag, otherwise ice cream will be very salty and disgusting. So that's a really, really fun activity. And as you'll know as scientists, obviously there's a lot of science that can be included about why we add the salt. Why do we put salt in there? Talking about melting points. So we can bring in melting points here. We can also have to decorate our ice cream with some sort of chocolate doodles. We can melt our chocolate. Why is our chocolate solid at room temperature? Why might we keep it in the fridge here? And so on. So the whole point of what we're trying to do is to continue to return to the same learning objectives in different contexts. So I've just given you an example of how when we think about particles, 2 of the different topics where particles come in. And again, it's revisited in Year 8 and Year 9 in different contexts. This, if anyone's interested, this scheme of work, this whole thing is called Wicked Science, and we've had to develop it a lot to make it suitable for us and for our children. So if you're interested in that, then of course come and speak to me. But I'd like to stress that if you just get Wicked and think, let's go, you need to really adapt it to make sure that it's right for your students. And we feel we're at a point now where we've picked out the best of Wicked, we've got the best of the contexts, and now our students are really, really gaining from this context-led approach. So thanks very much for listening. Does anyone have any questions or anything they'd like to... Oh no, hang on, actually, maybe I'll talk a bit more about this. Do a bit more on this. So students hopefully find this experience a lot more memorable. They find that they can remember. I mean, students I taught in Year 7 2 years ago who are now in Year 9, say, remember when we made ice cream? You know, they can remember the context, so hopefully that will help them to remember the science. And another point I'd like to make is this is also really important for staff and developing staff. This idea of context-led teaching is, you know, a really vital one in teaching across any subject. And we think it's really important that our staff are being exposed to the latest kind of teaching techniques and really helping them develop their practice and change themselves as practitioners, rather than, you know, standing at the front, lecturing to the students, giving them a worksheet and a story. This way, the teacher is having to adapt to the new types of teaching with role play, with group work, with discussion, in a far more, you know, enforced way. So we think it's excellent for our students and for the staff. So I will stop there. So does anyone have any questions?
Does Wicked Science saying is mainly for visitors?
Yes, so Wicked Science, the programme is for years 7, 8 and 9, so ages 11 to 14. So it prepares them for GCSE. And we found that a lot of the concepts, they're much more able to cope with the GCSE concepts once they've been through this, because they keep revisiting them. They develop skills along the way that previously they didn't develop. So we found it's an excellent basis for GCSE. Any other questions?
Sorry, this Wicked Science, is it a program, is a website, or is something that we have to purchase?
So it's something that you have to buy.
Okay.
It's made by the ASE, the Association of Science Education in the UK, and you pay. It's not a huge fee, but then you have access to everything, all the PowerPoints, the lesson guides, the the worksheets, the everything, teacher guides. So there's a lot there. I think it's really, really worth it. Even if you just pick and choose just a few things to introduce, and don't teach it the whole way, it's excellent.
Thank you.
There's something that e-chalk is also there.
Yeah.
It's pretty good.
Yeah, e-chalk's got some fantastic resources on it. Really, really engaging. Well, I think that'll do that if no one's got any more questions. Thanks very much for listening.